Chapter 5, Section 2, Congruent Polygons. We should know what congruent is, congruency, on how to find congruency and where congruency is. So this shouldn't hopefully be an easy lesson. This should hopefully be an easy lesson because it's information that we kind of already know. So looking at the first one, congruent figures. It says two figures that have the same size and shape. Okay, we should know what congruent means. That one's pretty easy. All corresponding parts of one figure are congruent to the corresponding parts of the other figure. What does that mean? We should know what the word corresponding means because we dealt with it in chapter 3. So corresponding means something like in relationship to, okay? So they're kind of corresponding in the same position. So when I'm looking at these two diagrams, I would name these as triangle ABC is going to be congruent to triangle FED, and I'll tell you why they're congruent and how do we know. Do we see the curves on the angles? Those we should know are my congruent marks. And the little tick marks are my congruent marks for my segments. You have to have 3 congruent marks for sides, 3 congruents for angles, and then you know that your triangles are congruent. So I'm writing them to be congruent. Please keep in mind, think of it as like a matching game. You're matching what's congruent. So I'm going from A to B and B to C. I'm doing the exact same thing for the other one. F to E. E to D, these have to be specifically written in an order. If it's not written in the correct order, it will be incorrect. So what am I matching? I'm matching my A with my F. So you could kind of see that it's highlighted with that color. Okay, my reds with my reds. Then I have my B with my E. Those are going to be congruent together. So A and F, B and E. I'll do it on the top. And then my last one is going to be my C. C is going to be congruent with D. So those are going to be congruent. What else do I know is congruent? Okay, I'm going to go ahead and name my corresponding angles. What angles are congruent? So I have 3 corresponding congruent angles. Okay, so again, I'm going to go ahead and write them how we normally do. I have angle A is congruent to angle F. I have angle B is congruent to angle E. And then I also have angle angle C is congruent with angle D. Okay, so that's what's congruent. So because I'm using those congruent marks, the little curves, I'm matching what goes with what. These have 1 congruent mark, these have 2, the 2 are going to go together, and then the 3 are going to go together. Now I'm going to go ahead and name my 3 congruent sides. 3 corresponding congruent sides. So again, I'm looking at my little tick marks. I have from A to B, F to E. It has 1 tick mark. Segment AB is congruent to segment FE. Yes, you can flip these around and say BA and EF. Then I have angle BC and DE. And then my last one, I have AC and FD. So kind of just showing you what's congruent to what. So I have 3 congruent sides, 3 congruent angles. That makes my triangle congruent in same size and same shape. All right, 3 angles theorem, you could abbreviate it. You could write it as third angles theorem instead of writing the whole thing out. What this says is if two angles of one triangle are congruent to the two angles of the other triangle, then the third angles are also congruent. Okay, so looking at the diagram, if angle A is congruent to angle D, so A and D are congruent. Again, they're showing you using the little congruency marks. And angle B is congruent to angle E, then we should know angle C will be congruent to angle F, and I'm going to give you an example. So how would I know these are congruent? Let's just think of our measurements. If they're giving me measurements, let's say this was 20 degrees right here, and this was 100 degrees. Okay, if they're congruent, what would the measure of angle C be? What would the measure of angle C be? Yeah. 60. Good. I have to have a total of 180 degrees. So looking at it, if this was 60, this one would also have to be 60 if they're all the same measure. So I'm just giving you an examples with the measurements to show you that the third one will always be congruent if the other two are also congruent. So this is called third angles theorem. Please don't forget that because you will see this one in a proof. This is called third angles theorem. It means my third angle will also be congruent. All right, properties of congruent triangles. We've seen these before. There's nothing new. Except instead of saying reflexive property of angles, now we're dealing with triangles, so congruent triangles. So looking at this one, I have reflexive property of congruent triangles, just means they're the same thing. Triangle ABC is congruent to triangle ABC. Symmetric property of congruent triangles, you're switching the order, it's symmetric. So triangle ABC is congruent to triangle DEF. Then DEF is congruent to ABC. I am not changing my letters around. I'm just changing my entire statement around. So please be aware of that. And then the last one was transitive property. We've done transitive property before. So looking at what's transitive, if ABC is congruent to DEF and DEF is congruent to JKL, then ABC is congruent to JKL, so I'm getting rid of this overlap right here. And that's my transitive property of congruent triangles. All right, looking at these examples, complete with always, sometimes, or never. So looking at number one, an acute triangle is blank congruent to an obtuse triangle. Is that sometimes, always, or never? Could an acute triangle blank be blank congruent to an obtuse triangle? Yeah. Never. Good. This is never. It's never congruent to an obtuse triangle. Looking at the next one, a polygon is blank congruent to itself. Sometimes, always, or never. Yeah. Good. To itself is always. A right triangle is blank congruent to another right triangle. Think about this one. A right triangle is blank congruent. Good. This is sometimes. Sometimes, keep in mind, the right angle of a triangle is only one angle. The other two can be different numbers, but they can sometimes be the same. So this is sometimes. Looking at the next one, pay attention to what they're asking for. It says if triangle ABC is congruent to triangle XYZ, then angle A is blank congruent to angle Y. Sometimes, always, or never. Yeah. Okay, this one's a little tricky. I'm going to go ahead and draw it out. If I were to give you a triangle, let's just use a right triangle since they've been asking about right triangles. And I have A, B, C. So yes, if they're in a statement form, normally say the order it's in is what's congruent. So yes, you can tell that your A and your Y are in two different positions. However, if I were to give you triangles like this, and I were to say this was 45, 45, and this was also 45, what makes Y? What would the measure of Y be as well? I heard someone say it. Who said it? What would the measure of Y be for this triangle for XYZ? So doesn't that make A and Y congruent? So what would my answer be for this one? Sometimes. Okay, this one would be a sometimes. Okay, so this was for number 4. Now looking at number 5, if triangle ABC is congruent to XYZ and angle A is blank congruent to angle X, what would this one be? Keep in mind they're in the same corresponding spot, so what would this one be? Sometimes, always, or never? Always. Good, this one would be always. Okay, questions on example number 1? Okay. All right, example number 2, it says in diagram ABCD is congruent to FGHK. I'm just going to go ahead and mark what's congruent. My A is with my F. My B is with my G. My C is with my H because they're congruent, and D is with K. Okay, first they want us to find the value of X. Let's do that. Value of X, which one would I be solving for? Where is X? Keep in mind both of these have an X, but I have to do this one first. I cannot solve the one with a Y in it. I have to solve for this one first. So if we're looking at this diagram, find the value of X. That's what I'm doing first. X is which side? X is going to be a side. So if I'm trying to find this value right here, looking at my other diagram, what's congruent to GF? GF is congruent to, say it one more time. Good, BA. So how would I set this up as an equation for me to solve? Go ahead.
3x minus 6 equals 9.
Good, equals 9. Okay, so all I'm doing is now solving for X. Add your 6 to both sides. 3x equals 15. Divide both sides by 3, and X is going to equal my 5. All right, because I did that, now I can go ahead and I can go and solve for Y. Where is Y? What angular side? Y is where? What angular side is my Y? Yeah.
FK.
So it's not FK, it's not a side. Look at where the arrow's pointing.
Oh, angle.
Good, it's going to be an angle. Keep in mind if they're giving you the little degree sign, that could also be a pointer that says it's an angle, because angles are always in degrees. So angle K is congruent to which angle? Yeah, angle D. So I'm going to go ahead and highlight that one. And then setting it up as an equation, I'm going to have 4x plus 2y equals 44, and I'm going to go ahead and plug in that x. 4 times 5, because that's what we solve for x, plus 2y equals 44. 20 plus 2y equals 44. Subtract 20 from both sides. 2y equals 24. Divide by 2, and your y is going to equal 12. So if you solved correctly and you found what was congruent, that one should hopefully have been pretty easy. But just understand when you're looking at the diagram, you have to solve for one variable first and then plug in. All right, example number 3, it says Maggie took the pieces of fabric STUV shown in the diagram and cut it on the diagonal to make a scarf for her and her friend. Are the two pieces the same size and shape? So let's go ahead and find what those two pieces are. So right now I have SVU. This is one piece of my triangle. And then I have STU. So remember, in order for something to be congruent, I have to have 3 angles and 3 sides to be congruent. So looking at this, I'm just going to go ahead and find what I have. I can find that there are 3 sides in this diagram. I have 3 corresponding sides. Okay, who could tell me one side that is congruent? Who could give me one side that is congruent? So looking at my diagram, what side would be considered congruent? Keep in mind, look at your congruency marks. Yeah. SV and TU, good. ST is congruent to TU. What's another one? Yeah. ST, or did I mess up on the other one? This one, yep. This one should have been not ST, SV. SV is congruent. Good, and this one you said ST and VU. ST is congruent to VU. And then I need you guys to understand, if there is something that is sharing a side, if they're sharing a side, then that means they're congruent. So right there in that bright blue, those 2 triangles are sharing a side. That side is going to be congruent. SU is congruent to US. So right now I just named all 3 of my sides. Now I have to go and find if there are 3 corresponding congruent angles. Okay, so are there any angles that are congruent? Looking here, which angles can I tell right off the bat without assuming are they congruent? There's at least one. Which one is that? Which angles do we know for a fact are going to be congruent? Yeah.
Angle SVU and angle STU.
Good. So angle SVU, which is right here, and STU, because there's only one, I don't have to name it using 3. I could just name it as angle V, and angle T would be fine. So I'm going to go ahead and name that one right here and right here. I have angle V is congruent to angle T. And going back to chapter 3, lines perpendicular to a transversal theorem. If I have perpendicular lines, which are all around me, my lines would be parallel, and this would be my transversal. So looking at my numbers that they're giving me, think of them as alternate interior angles. Which angles would be considered congruent? Which angles would be considered congruent? Yes.
Angle S and angle U.
Okay, angle S and angle U, but there's multiple angles within that, so I have to name it as one would be angle 1 is congruent to angle 4. Okay, so I'm going to go ahead and write my congruency marks. And then what's another one? Yeah.
Angle 2 is congruent.
Good. Angle 2 is congruent to angle 3. And these 2 things here are considered alternate interior angles. So if I named all 3 angles and all 3 sides, would this be a congruent figure? Congruent polygon, yes. Why? Same shape and size. they're going to be all congruent. So yes, this would also be considered. She cut it in half equally, same size and same shape. All right, looking at the last one, this one's a proof. I think these proofs are a lot easier. Key for these is draw it out. What do I mean by that? I'm going to show you. If they're giving you information, you're trying to prove something, draw the information you have or the information you know. So I'm going to go ahead and draw my little T-chart. I have my statements and my reasons. I am going to go ahead and put all of these together. I'm not going to separate them. I'm going to put them together. So I have SV is congruent to RV. TV is congruent to WV. ST is congruent to RW. And angle T is congruent to angle W. And how do I know? It's given. I want to prove that these two triangles are congruent. Remember, in order for triangles to be congruent, you have to name all three sides and all three angles to be congruent. So that's why I'm going to draw it. I'm going to draw what they gave me. So they told me SV right here is congruent with RV or VR. Should be one tick mark. Those are congruent. Then I have TV is congruent to VW or WV. That's my second congruency side. Then I have ST is congruent to RW or WR. That's my third congruent side. So right now all my sides are taken care of. Now I have to find all angles. ST is congruent to W. That's 1. Now, what do I have left? I'm missing these matching angles and these matching angles. Then I proved that the triangles are congruent. So I need 3 more statements and 3 more reasons. Looking at my diagram, what can I tell automatically is going to be congruent? Without even assuming, what do I know for a fact is going to be congruent? Yeah. Angle S and angle R, I can't really state those yet because I don't know if they're congruent. But what do we know is going to be congruent? Yeah. Yeah. S and W, we already said W is congruent to T, so it can't be S and W. If these are already taken care of, I can't use them again. So these two are congruent, so what else would be congruent? What else can we say is congruent? And tell me the reason, Brandon.
S and R.
Well, how would we know that those are congruent? Give me a reason. If you could tell me, then you could give me a reason. But how would we know S and R are congruent? I don't know S and R are congruent until I have to do something first. Laura?
Is it line ST and line WR?
So we already stated that. If I already have a congruent mark, I already stated that they're congruent, so I'm not going to use it again. So remember, what do I need? I need 2 more angles, but I need to do something before. Yeah.
Line TW is congruent to line SR?
Line TW is congruent to SR. I mean, yes, but we kind of took care of that by saying that these segments were congruent. What else can I say is congruent? Yeah.
Angle B is, like the vertical angle B is congruent.
Are vertical angles always congruent? Yeah, so I can say, before I say S and R, angle V is congruent. Well, I can't state it as angle V. I'm going to have to name it using 3 points. But we should always know, anytime you have a vertical angle, it's going to be congruent. So I cannot state S and R first. I have to state those vertical angles first. So yes, this vertical angle right here is congruent to this angle. So I know my reasoning, but how would I state it as angles? Remember, I can't say angle V and angle V. I would have to say angle SVT is congruent to angle RVW, and we know that why? Because vertical angles theorem, or vertical angles congruency theorem, because they're always congruent. Does that make sense? Now, can I state that S and R are congruent? Yes, I can, by using what theorem? By what theorem? So if you need to, look back because it's the one we did today. Yes.
Alternate interior.
Not alternate interior because I don't know that those lines are parallel. Yeah. Third angles theorem. Remember what third angles theorem is stating. Third angles theorem states if two angles of one triangle, so here are my two angles that we stated, if two angles from one triangle are congruent to the two angles in another triangle, then the third angle is also congruent. So that's what I'm using for this one. And this one's going to be, all I have to state now is angle S is congruent to angle R by third angles theorem. Okay, keep in mind I am not done as of yet. I have to write this one last. So for triangle STV is congruent to triangle RWV by definition of congruent triangles. Why is it definition of congruent triangles? Because I stated all three angles are congruent and all three sides are congruent, okay? So definitely it really helps to draw it out because it sees what you're missing when you're drawing the diagrams, okay? And put your little tick marks so you know what's congruent, and it could definitely help you. Questions, comments, concerns? Don't forget those vertical angles. Don't forget that one, okay? You guys have homework on big ideas. The questions you have to show work for and the questions you have to write the proofs out for are on Canvas. So go ahead and look that up.